Shapes works with any type of mesh, and starting with the version 5, it features improved symmetry functionality. Single and multi-shell meshes with topological symmetry are fully supported. Of course, this only affects workflows which require mirroring. If mirroring is not needed for the mesh, all you need to do is load the mesh and start working. Before we start looking at how to use the symmetry feature in the video Working with Symmetry Mapping, let's first be clear about what sorts of meshes are possible and supported by shapes. Most meshes are symmetrical, which means that the vertex count and topology is the same on both sides of the line of symmetry. Every point and its mirrored sibling share the same relative position. Loading this kind of mesh into shapes means the least amount of manual work. Some meshes can have smaller or even larger variations between both sides, even if the general topology is the same. This is described as topological symmetry. Vertex positions don't have to match. Working with these models usually requires manual input from the user to define an edge which marks the line of symmetry. When working with topological symmetry in shapes, selecting such an edge is not absolutely necessary. It only comes into play when shapes isn't able to find such an edge automatically, or when you want to make sure that a particular edge is being used. Shapes also supports meshes which don't have an edge at the line of symmetry. Older versions than Shapes 5 had the limitation that meshes with topological symmetry were limited to only one shell. This limitation does not exist any longer. Any mesh can be composed of multiple shells. Shells can be either spanning, meaning they have components on both sides, or they appear as a pair. Lastly, there are meshes which are only partially symmetrical. These meshes have the most limitations regarding mirroring. Not being able to properly evaluate the mesh through topology in a mirrored fashion means that only vertices with a matching position can be respected. All non-symmetrical components are ignored for these meshes. With this in mind, let's take a look at how to work with the symmetry mapping in shapes.